Welcome to Your Space Journey, where we venture into the future of space exploration. Your journey begins now.
Welcome back to Your Space Journey. Today, we're diving deep into some fascinating new research about Betelgeuse.
Oh, yeah.
That brilliant red supergiant star in the constellation Orion.
Yeah, it's always been a bit of a celebrity in the astronomy world.
Right, you don't even need a telescope to see it. But Betelgeuse has always been known for those dramatic shifts in brightness.
Oh, yeah.
And, lately astronomers have been really puzzled by this extra long dimming and brightening cycle.
Uh-huh.
It takes a whopping 2,170 days.
Almost 6 years. That's a really long time for a star to complete a cycle like this. And it's led to some pretty intriguing theories.
Like what? What could cause a cycle that long?
Well, the latest research is pointing to a potential companion star.
So Betelgeuse might not be as solitary as we thought.
Exactly. Astronomers have been carefully analyzing over a century's worth of data on Betelgeuse's movements and brightness.
Wow.
And what they found suggests there might be another star out there. A Beetle Buddy, as it's been nicknamed.
Wow, a Beetle Buddy. I love that.
Orbiting Betelgeuse and influencing its behavior.
So how did they figure this out? They haven't actually seen this companion star.
No, not directly. It's much fainter than Betelgeuse.
Right.
And its light is easily overwhelmed. But astronomers have been able to infer its presence through careful analysis of Betelgeuse's movements.
Okay.
We're talking about astrometric data, which tracks its position in the sky. Radial velocity data that shows its movement towards or away from us. And of course, photometry, which measures its brightness.
So by studying how Betelgeuse wobbles and changes in brightness over time, they've deduced that something else must be out there gravitationally tugging on it. That's some serious detective work.
It really is. And based on their calculations, they've been able to estimate some surprising details about this potential Beetle Buddy.
Okay.
It's likely much smaller than Betelgeuse. Probably about the mass of our own sun.
Wow.
And it orbits Betelgeuse at a distance similar to Saturn's orbit around our sun.
Hold on, Saturn's orbit, that's huge.
It is in our solar system.
Yeah.
But in terms of Betelgeuse's scale, it's remarkably close. Think of it this way. It's about one Betelgeuse width away.
Wow. That puts things into perspective.
Yeah.
But how does this Beetle Buddy explain those long dimming and brightening cycles?
Well, that's where things get even more interesting. It's not a simple eclipse.
Right.
Where Beetle Buddy passes directly in front of Betelgeuse.
Okay.
And blocks its light. Instead, researchers believe Beetle Buddy might act as a sort of dust-clearing snowplow through the material that Betelgeuse sheds.
Okay, I'm definitely intrigued.
Yeah.
A dust-clearing snowplow. How does that work in space?
Well, as you know, Betelgeuse is a supergiant star.
Right.
And supergiant stars shed a lot of material, dust, and gas.
Yeah.
This material forms a sort of cloud around the star. As Beetle Buddy orbits Betelgeuse, its gravity might be clearing a path through this material.
So during certain points in its orbit, Beetle Buddy sweeps away the dust, allowing more of Betelgeuse's light to reach us.
Exactly.
Making it appear brighter. And then, as Beetle Buddy moves along its orbit, the dust might partially obscure Betelgeuse again, causing the dimming periods.
Yeah, you got it. It's like a cosmic dance.
Wow.
With Beetle Buddy influencing the flow of dust and gas around Betelgeuse. And we see the effects of that dance as these long-term changes in brightness.
You mentioned all that dust that Betelgeuse sheds. Do you think Beetle Buddy's position might have contributed to that dramatic great dimming event we saw back in 2019 and 2020? When Betelgeuse dimmed so much that some people thought it was about to go supernova?
That's a great question. It's one that astronomers are actively investigating.
Yeah.
It's certainly possible that Beetle Buddy's gravitational influence could have affected the distribution of the dust cloud, contributing to the dimming. But more research is needed to confirm that.
So while we haven't directly seen Beetle Buddy, we have all this evidence suggesting it's out there.
Right.
Playing a significant role in Betelgeuse's behavior.
Yeah.
That's incredible.
It really highlights how much we can learn about the universe through indirect observation and careful analysis.
Yeah.
And this is just the beginning. The James Webb Space Telescope and the upcoming Nancy Grace Roman Space Telescope will give us even more powerful tools to study Betelgeuse and its mysterious companion. Who knows what other secrets they'll reveal?
I can't wait to find out. But before we get ahead of ourselves,
Okay.
let's delve a bit deeper into the implications of this research.
Sure.
What could the presence of Beetle Buddy mean for Betelgeuse's ultimate fate? The whole supernova thing everyone's talking about.
Yes, the supernova. That's where things get really fascinating and perhaps a bit more complex than we initially thought.
All right, well, let's take a moment to hear from our sponsors, and we'll dive into that right after this.
If you're enjoying this interview, be sure to subscribe. Thanks for listening.
So you're curious about what Beetle Buddy could mean for Betelgeuse's eventual supernova.
Absolutely. Everyone always talks about Betelgeuse going supernova. It's kind of a big deal.
Rightly so. It's one of the closest supergiant stars to Earth. And when it does eventually explode, it'll be a spectacular event.
But how does Beetle Buddy fit into all of this?
Well, the presence of a companion star can actually influence what kind of supernova a star experiences.
Okay.
And this is where the details of Beetle Buddy's orbit become really important.
Okay. I'm all ears.
Yeah.
What kind of supernova are we talking about?
Think of it this way. A supernova is a star's grand finale. A massive explosion that marks the end of its life.
Right.
But there are different types of supernovae, each with its own unique characteristics.
Okay.
Some are more energetic than others.
And Beetle Buddy could influence which type Betelgeuse experiences.
Exactly. If Beetle Buddy's orbit is close enough and the conditions are right, its presence could trigger a more powerful supernova.
Wow, that's incredible. But would a more powerful supernova be dangerous for us here on Earth?
That's a common question. But don't worry, even a super-powered supernova from Betelgeuse wouldn't pose a direct threat to life on Earth.
That's good to hear. But I'm still curious. What will we actually see if Betelgeuse went supernova?
Imagine this Betelgeuse, which is already one of the brightest stars in our sky,
Right.
suddenly becomes even brighter,
Wow.
outshining almost everything else. It could even be visible during the daytime.
Wow, that would be amazing to see. How long would it last?
The intense brightness could last for weeks, maybe even months,
Wow.
gradually fading over time. It would be a celestial spectacle unlike anything humanity has ever witnessed.
I can't even imagine. But beyond the visual spectacle, what would happen on a cosmic level?
Supernovae are incredibly important events in the universe. They're responsible for creating and distributing heavy elements, the building blocks of planets and life itself.
Wait, so the elements that make up our bodies, the Earth, everything around us, they came from supernova explosions.
That's right. The intense heat and pressure of a supernova forge elements heavier than iron,
Wow.
like gold, silver, and uranium. These elements are then scattered throughout the galaxy, eventually becoming part of new stars, planets, and even life.
So when we look up at Betelgeuse, we're not just seeing a star, we're seeing a potential source of the very elements that make up our world. That's mind-blowing.
It really puts things into perspective, doesn't it?
It does. But I have to ask, you keep saying eventual supernova. When is this going to happen?
That's the million-dollar question. Unfortunately, predicting exactly when a star will go supernova is incredibly difficult.
But didn't you say the Beetle Buddy could provide some clues?
Yes, but it's more complicated than that.
Okay.
Betelgeuse's internal structure, the exact nature of its relationship with Beetle Buddy,
Right.
the rate at which it's losing mass, all these factors play a role in determining when the big boom will occur.
So we don't know for sure if it's going to happen tomorrow or 1,000 years from now.
Exactly. But based on current models, most astronomers believe Betelgeuse will likely go supernova within the next 100,000 years.
Okay, so maybe not tomorrow. But that's still relatively soon in cosmic terms.
It is. And as our understanding of stellar evolution improves and our telescopes become even more powerful, we'll be able to get a much clearer picture of Betelgeuse's future. Who knows? Maybe we'll even be able to narrow down the time frame for its supernova.
I hope so. It would be amazing to witness such a momentous event in our lifetime. But, thinking about Betelgeuse and its potential companion star, this whole dust-clearing snowplow idea, it's amazing how much we can learn about the universe without even directly seeing something.
It's true. Sometimes the most fascinating discoveries come from indirect observation. From piecing together clues and looking for patterns. It's like a cosmic puzzle. And we're slowly but surely putting the pieces together.
It makes you wonder, what other mysteries are hiding out there in the universe, waiting to be uncovered?
That's the beauty of astronomy, isn't it? There's always something new to discover.
Right.
Always something that pushes the boundaries of our understanding. And who knows? Maybe one day, someone listening to this will make the next big breakthrough.
That's a great thought. But before we get too lost in speculation,
Okay.
I think it's time to turn our attention to the tools that might help us solve these cosmic puzzles.
You're talking about the next generation of telescope.
Exactly. And one in particular has the potential to revolutionize our understanding of Betelgeuse and its mysterious companion.
Ah, yes. The Nancy Grace Roman Space Telescope. It's going to be a game changer, but we'll save that discussion for the final part of our deep dive.
So we've been talking about the possibility of actually seeing Beetle Buddy with this new telescope.
Yeah.
What makes the Nancy Grace Roman Space Telescope so special?
Well, the Roman telescope is going to be equipped with a powerful tool called a coronagraph. Essentially, it's designed to block out the light from very bright objects.
Like Betelgeuse.
Exactly. By blocking out Betelgeuse's glare, the coronagraph will allow astronomers to observe much fainter objects nearby.
So it's like creating an artificial eclipse.
Yeah, that's a great way to think about it. And with the Roman telescope's sensitivity,
Yeah.
we're not just talking about catching a faint glimpse. We might be able to get detailed images and even spectroscopic data of Beetle Buddy.
Spectroscopic data. What can you learn from that?
Spectroscopy allows astronomers to analyze the light from an object and break it down into its component wavelength.
Yeah.
Think of it like a fingerprint.
So each element has its own unique spectral signature.
Precisely. By studying Beetle Buddy's spectrum, astronomers can determine its temperature, composition, even its speed and direction of movement.
Wow.
It would give us a wealth of information about this mysterious companion.
It would help us understand its relationship with Betelgeuse and how it's influencing the supergiant's behavior.
Exactly. And that information could help us answer some of the big questions we've been discussing. So which of Betelgeuse's cycles is its true heartbeat?
Right.
And how that might affect its supernova timeline.
I'm starting to see how the Roman telescope could really revolutionize our understanding of Betelgeuse. It's almost like we're on the verge of a whole new chapter in this cosmic story.
It really is an exciting time for astronomy, and it makes you wonder what other mysteries are out there, just waiting for the right tools to unlock them.
We've learned so much about Betelgeuse already, even without directly observing Beetle Buddy. Just imagine what we might discover when we can finally see it. It's a good reminder that sometimes the most amazing discoveries come from looking at things from a different angle.
Yeah.
From thinking outside the box.
Absolutely. And from being patient. Astronomy often requires a lot of patience.
It's true. But when you consider the vastness of the universe and the timescales involved, it puts things into perspective. A few years, even a few decades, it's just a blink of an eye in the grand scheme of things.
It is. And for those of us who are fascinated by the cosmos, that sense of perspective can be both humbling and incredibly inspiring.
Absolutely. It makes you appreciate the interconnectedness of everything. The elements that were forged in the heart of ancient stars are now part of us, part of our planet, part of everything we see around us. And one day, those elements will be recycled back into the universe when Betelgeuse goes supernova.
It's a beautiful and awe-inspiring cycle. And who knows, maybe someone listening to this right now will be part of the next generation of astronomers who will witness and study Betelgeuse's grand finale.
That's a great thought to leave our listeners with. Keep looking up, keep exploring, and keep wondering because the universe is full of surprises. And as we've seen with Betelgeuse, even the stars we think we know best can still hold incredible mysteries.
Until next time, keep exploring the cosmos.
Your space journey.